So this is Chapter 6, Section 5, Solving Square Root and Other Radical Equations. Our learning objective is to solve square root and other radical equations, such as cube root, fourth root, etc. So a radical equation is an equation I like to serve. Just kidding. It's an equation that has a variable in a radicand or a variable with a rational exponent. So if the radical has an index of 2, the equation is a square root equation. So we definitely need to write this part down in this box. So our essential understanding is when we solve a square root equation, we may have to take the square of both sides, and when we do that, we may get a solution that doesn't work with the original problem. That's called an extraneous solution. We encountered those when we did absolute value equations. So similar type where we have to test our solution. So our whole purpose is we're going to isolate, so we just have the radical on one side of the equation, everything else on the other. Then we are going to raise each side of the equation. If it's square root, we're going to square it. Cubed root, we're going to cube it. So let's take a look at what that's going to look like. So if I have the square root of 4x plus 1 minus 5 equals 0, we are going to want to isolate just the square root. So we're going to add 5 to both sides. To get rid of a square root, we have to square both sides of the equation. So a square gets rid of a square root. So we just get 4x plus 1, and 5 squared is 25. Now we have a simple basic algebra 1 equation. 4x plus 1 equals 25. So we subtract 1 from both sides. 4x equals 24. Divide by 4 and we get 6. Please do not go type in 6, submit your answer. When you square both sides for fourth power or raise any two sides to a power, make sure you check your solution. So we're going to take our original equation. Where there was an x, we're going to put in 6. So we got 4 times 6 is 24. Plus 1 is 25. Square root of 25 is 5. 5 minus 5 is 0. So it checks out. Got to make sure you're checking for those extraneous solutions. When you have a crazy fraction as an exponent, so that's x to the m over n equals k, we are going to raise each side to the reciprocal power, m over n. So if either m or n is even, then we get out an absolute value. We did a whole section yesterday on that situation. So let's take a look at how that looks here. And I'm going to have to add in absolute value here. That'll be great. So we got 2 parentheses x plus 3 raised to the 2/3 power. That's going to equal 8. We want to solve for everything that is not to the power of 2/3. So we're going to first divide both sides by 2. So if anything is on the outside of either the root or the fractional power, we're going to get rid of it. If we can move it to the other side, we're going to move it to the other side. So then we have x plus 3 raised to the 2/3 power equals 4. This is the scenario that we were talking about up here. We have to raise both sides of the equation to the reciprocal power. So the reciprocal of 2/3 is 3/2. So we're going to raise both sides to the 3/2 power. And in this situation, if either m or n is even, so because I have a 2, I'm going to get x plus 3, but he's going to have absolute value. Absolute value of x plus 3 equals 4 to the 3/2. So now we have to solve absolute value equation. And when we do that, we get two different equations. So let me start that over here. X plus 3 absolute value equals 4 to the 2/3, or 3/2, sorry. So let me take off. So I'm going to get two separate equations. The equation as it stands within the absolute value and the one when it's negative 4 to the 3/4. So let's go ahead and solve this one first. So x plus 3 equals 4 to the 3/2. I'm going to subtract 3 from both sides to get x isolated. I chose in 4 to the 3/2. You can either cube the 4 and then take the square root, or you can square root the 4 and then cube it. I'm going to choose to square root the 4 first and then cube it. So remember, the denominator is the root and the numerator is the power. So square root of 4 is 2. Two to the 3rd power is 8, and 8 minus 3 is 5. This is my Chuck. He didn't get animated, so he just gets to stay there the whole time. All right, so now I'm going to solve this guy. He is, and just a reminder, when we have absolute value, to solve it, we branch it off into two problems, the one with where the right-hand side is positive and the one where the right-hand side is negative. We're taking care of both solutions. So here we're going to go subtract 3 from both sides. So x is equal to negative 4 to the 3/2 minus 3. So remember, 4 squared is, square root of 4 is 2, and 2 to the 3rd power is 8. So this is equal to negative 8 minus 3. Negative 8 minus 3 is negative 11. So that's my other solution. So now I have to check both of those solutions. So let's go ahead and check x equals 5 first. So when I put it into here, click on, so I got 5 plus 3 raised to the 2/3 power equals 8. I have 5 plus 3 is 8. And then 8 to the 2/3 power. I'm choosing to cube root 8 first because I know the cube root of 8 is 2. So instead of squaring 8 first. So cube root of 8 is 2. Then I have 2 squared is 4. 2 times 4 is 8, and 8 does equal 8. All right, now I have to check the x equals 11. This was x equals 5. x equals 11, so it's, sorry, negative 11. So it's 2 times negative 11 plus 3 to the 2/3 power equals 8. 2 times negative 8 to the 2/3 power equals 8. I'm going to go ahead and cube root negative 8. The cubed root of negative 8 is negative 2. And negative 2 squared is 4. Is 2 times 4 equal to 8? Heck to the yeah. So both of these solutions check out. X equals negative 11 and x equals 5. All right. When you raise the side of an equation to a power, it is possible to introduce extraneous solutions. Like we saw, the two that we just did weren't extraneous, but therefore it becomes very important that you check all solutions in the original equation. A correct solution will give a true statement, an extraneous solution will give a false statement. So let's try this one here. I'm looking, I did not do the answers this way. Okay, so what is the solution of square root 5x minus 1 plus 3 equals x? So we are going to get rid of everything except the square root, which means minus 3 to both sides. And then to get rid of the square root, we're going to square both sides. Yeah, 5x minus 1 equals x minus 3 squared. Just to remember, x minus 3 squared is x minus 3 times x minus 3. The trick to squaring a binomial is you take the first term and square it, take the last term and square it, and then you take each item 3 times x, and you double it to get the middle term. Or if you, I just happen to have that memorized. If you don't want to memorize that, you can FOIL it all out and get x squared minus 6x plus 9. So x minus 3 becomes x squared minus 6x plus 9. All right, so we have a nice little quadratic equation. We spent most of last chapter fussing with these solving quadratics, so we're going to move everything, and in this case, I'm going to move the 5x and the minus 1 over to the right-hand side, and that'll keep my x squared nice and positive in case I want to factor it. So I minus 5x from both sides, and I add 1 to both sides. I get x squared minus 11x plus 10. Oh, heck yeah, I could totally factor that. I got this, guys. This factors 2 factors that add to give us negative 11 and multiply to give us 10 are minus 1 and minus 10. So now here's my 2 solutions. I have x minus 1 equals 0 and x minus 10 equals 0. So both of these become a part of our solution. Adding 1 to both sides. I get x equals 1 and x equals 10. Please, before you just click on, oh yeah, that's B. Click on B, submit the answer, move on. They're trying to warn you, check your work, check the solutions. If you don't check, you will get caught up, and that is an easy one to not have to get wrong. So we're going to check both of these solutions. We'll check x equals 1 over here, and we'll check x equals 10 over here. So we're going to go square root of 5 times 1 minus 1 plus 3 equals 1. Everywhere there's an x, we put a 1. Square root of 5 minus 1 plus 3 equals 1. Square root of 4 plus 3 equals 1. Square root of 4 is 2. Plus 3 is, of course, 1. Do math, guys. 5 equals 1. No! Not even in new math does 5 equal 1. So x equals 1 is not a solution. So let's check the 10. So we're going to go square root of 5 times 10 minus 1 plus 3 is 10. Let's see where this is going. 5 times 10 is 50. 50 minus 1 is square root of 49. Square root of 49 is 7. And 7 plus 3 is 10. Yay! So this is our solution. X equals 10. Star. All right. Oh, I was like, didn't we just do this problem? Nope. If an equation contains 2 radical expressions or 2 terms with rational exponents, so now we're getting a little bit harder. Each one is a little harder and a little bit harder. Isolate one of the radicals or one of the terms, then eliminate it. Isolate the more complicated radical expression first. In the resulting equation, simplify the expressions before you eliminate the second radical. Okay, so let me show you what they mean by that. So I want to get an expression where the most complicated radical is on its own. So what's more complicated? Square root of 5x plus 4 or square root of x? This guy's more complicated. He's got more stuff going on inside of him than this guy. So I'm going to go ahead and move my square root of x over so that I get 5 square root of x plus 4 and 4 plus square root of x. Please ignore the blue for just a moment. Once again, I couldn't get that animated. I don't know. You just say nothing. Try for 5 minutes, then you just give up. So I get square root of 5x plus 4 and 4 plus square root of x. The very next thing that we're going to do is we're going to square both sides. When we square both sides, we get 5x plus 4 because the square undoes the square root. And then, unfortunately, wouldn't it be nice if it was just like 16x squared or 16x? But it's not. Because 4 plus the square root of x squared is 4 plus root x times 4 plus root x. And then we got to FOIL that out. Unfortunately, I'm so sorry. I know it's work. So we get 4 times 4, which is 16. We get 4 times root x. I'll put it in. It'll be the baby section in here. So this is, I FOIL 4 times 4 is 16. 4 times root x is 4 root x. Root x times 4 is 4 root x. And then square root of x times square root of x is just x. Then my 4 square root of x's, we got 2 of them. Remember we did that section where we're adding rational expressions together? Oh my gosh, yeah, now it's coming together. 4 square root of x plus 4 square root of x is 8 square root of x's. 16 goes here and x goes there. Oh my gosh! So now, let's call this phase 2. Now it's like we have started over with a brand new problem. We have to get the square root by itself on one side and everything else on the other. So we're going to subtract 16 from both sides. So I'm going to subtract 16 from both sides. We get 5x minus 12 equals 8 root x plus x. I'm going to subtract an x from both sides and get 4x minus 12 equals root 8x. And then I have a decision. I could divide everything by 8, but does 4 divide by 8 evenly? No. And does negative 12 divide by 8? No. So if I divided by 8, it would give me some fractions. And do I feel like squaring fractions? No. So I am going to go ahead and straight off just square both sides from here. So I get 4x minus 12 squared, which is 4x times 4x is 16x squared. And if I use the squaring a binomial property where we go 4 times negative 12 doubled, that's negative 96, so that's minus 96x. And then negative 12 times negative 12 is positive 144. 8 squared is 64, and the square gets rid of the x. We gotta send the 64x over to the other side of the equation. When we do that, we get 16x squared minus 160x plus 144 equals 0. Thank goodness. These are giant numbers. Thank goodness all these numbers divide by 16. I wasn't sure about 144, so I had to test it. In my calculator, I did 144 divided by 16. But I knew 16 divided by was divisible by 16. Negative 160 was divisible by 16. And so I was like, fingers crossed that 144 is going to divide by 16. All right, so we pull that 16 out, and then we factor this x squared minus 10x plus 9. If we go negative 9 and negative 1, they add to give us negative 10, and they multiply to give us positive 9. So our solutions to this problem are x equals 9 and x equals 1. What happens to the 16? We just divide both sides by 16, and 0 divided by 16 is 0. So he goes away. All right, so now we have to check our solutions, and then we can write a summary. Thank goodness. Okay, so let's go ahead and check 9 and 1. So if I plug 9 in for x, I get 5 times 9 plus 4 underneath the square root minus the square root of 9 equals 4. Oh, he went off the page. It's crazy. All my check is over here. Do I have, oh yeah, I can go over there. Okay. And I have 5 times 1 plus 4 minus the square root of 1 equals 4. So 5 times 9 is 45, plus 4 is 49, square root of that is 7. Negative root 9 is minus 3. 7 minus 3 is 4, and that is equal to 4, so that checks out. So we're going to check out the 1. 5 times 1 is 5, plus 4 is 9, square root of 9 is 3. Negative 1, or sorry, minus the square root of 1 is minus 1. 3 minus 1 is 2. 2 is not equal to 4, so we know that 9 is our real solution.